Okay, stats, let's finish 10.1. Starting at page 4, as a reminder, just like a trial, whether someone is guilty or not guilty, you either reject or don't reject. So you never accept. So the idea is that you never have a trial where someone says, we find the defendant innocent. We find the defendant not guilty. So there is no accepting H naught at the end. It's don't reject or do reject the null hypothesis. So please don't make your conclusion say we accept H naught. You either reject it or you don't reject it. Basically you're saying either I have enough evidence to say that I believe this isn't true, or I don't have enough evidence to do it. Now, notation. When you see the notation alpha, this is the probability of a type 1 error. This is usually decided at the beginning based on how bad making a type 1 error is going to be. This is the equivalent of a confidence interval, kind of. It can be one-sided, and we'll talk about that more later. But it's like, if you only need 90% confidence, you don't need to be that confident. But sometimes you need to make sure you get it 99%. You need to squeeze your chance of making an error. However, the wider you go to search, the more likely you are to make a type 2 error. So there's a trade-off. Now beta, this is alpha and beta, is the probability of a type 2 error. So why is there a trade-off between these two? If you cast a wider net to make sure you hit your data, you have a bigger chance of not rejecting H naught when it actually should have been rejected. Basically, if you take 99 out of 100 results and say all of those are okay, there may be like 3 or 4 which would have indicated otherwise that they weren't okay and you could have been wrong. So that's a trade-off depending on what happens. So let's look down to 1 and 2 at the bottom of page 4. All we're doing here is explain what it means to make a type 1 error, what it means to make a type 2 error. So in 2008, 62% of American adults regularly volunteer their time for charity work. Same problem. A researcher believes this percentage is different today. What would it mean to make a type 1 error? Type 1 error is, again, rejecting H naught when H naught is true. So that would be saying type 1 is concluding the number is different today, even when it still is around, even when it's still true. Now, what is a type 2 error? Type 2 error would be concluding that it's still 62% when it's actually changed. I mean, it's probably changed now because of Corona, but that's neither here nor there. So the idea is one of them, you decide that it's different when it actually isn't different, and the other one is you decide it's not different when it actually is. So it's very slight differences there. Let's look at number 2. So it's the same, the phone call one, where according to a study published in March 2006, the mean length of a phone call on a cell phone was 3.25 minutes. And the researcher believes the mean length of the call has increased since then. So when it's only increase or decrease, this is a little bit different. Type 1 would be concluding the number isn't different, but since she only wants to test if it's increased, the number has to be is higher, even though it isn't. Type 2 would be concluding it's still around 3.25, even though it's increased. Notice that decrease is not anywhere in here. The reason is when you're testing only one side, you don't care if you notice it decreases. That is not what you're testing. It's like if you are having a scientific experiment and you make a hypothesis on a conclusion. If you find something else out along the way, you don't make a conclusion about that. It's not what you were testing. You would have to go back and do a different experiment again if you wanted to learn about that. So let's go to page 5. Let's practice writing conclusions. We usually give a very blank general statement. So we're going to go back to the phone call experiment. According to a study published in March 2006, the mean length of a phone call on a cellular phone was 3.25 minutes. A researcher believes that the mean length of the call has increased since then. Now, suppose she runs the experiment and she finds out that there's evidence that the null hypothesis should be rejected. Basically, she finds evidence, strong evidence, that it is greater than 3.25. Remember, our conclusion always relates to the null hypothesis, so we should say things like, there is sufficient evidence to conclude that the mean length of a call on a cell phone is greater than 3.25 minutes. And if you don't want to write that, I will always let people write, there is sufficient evidence to conclude that. That way it can save you some time writing, and I'll know what that means. I just need the there is or is not before that, so we know what this is going to be. Now, what happens though if, let's write a conclusion, if she finds evidence and there's not enough evidence to reject? So instead of saying there is sufficient evidence to conclude, we would say there is not sufficient evidence to conclude that the mean length of a phone call on a cell phone is greater than 3.25 minutes. So this is really just practice getting used to, we haven't done any math yet for a reason. This is just you getting used to how this is going to work. So in 10.2, we'll actually do some math and see how you'll take the process from beginning to end. But for now, it's just about you being comfortable with how this works. And that's all until Wednesday.